Hello everyone, I am Prakhyath Jain, Assistant Professor, Department of Mechanical Engineering, HIT Mangalore. Today I am going to discuss about Module 4 of Fluid Mechanics, that is Dimensional Analysis. Topics include dimensional homogeneity problems and Rayleigh's method problems. So before going to the problems, let us first recall the concepts of dimensional homogeneous and Rayleigh method. So what is dimensionally homogeneous equation? So equation which has same unit on both sides, that is LHS unit should be equal to RHS unit, or a equation which has same dimension on left hand side as well as right hand side, then such a equation is called dimensionally homogeneous equation or dimensionally homogeneous problem. So what is Rayleigh method? So Rayleigh method, there are two methods of solving the problem using dimensional analysis. In that, first method is Rayleigh method and second method is Buckingham's pi theorem. So I already discussed about Rayleigh method. It has a drawback of it can be applied to a problem which has maximum 3 to 4 independent variable, and again I discussed about procedure of solving the problem using Rayleigh method. So let us first go for solving the problem related to dimensional homogeneity. So first problem, check whether the following equations with their usual notations are dimensionally homogeneous or not. First one, HF equal to 128 Q into mu into L divided by gamma into pi into d to the power 4. Second one, P equal to 4 sigma by d. And third one, M dot equal to rho AB. And fourth one, P equal to rho GH. And fifth one, P equal to F by A. Now let us first go for sub question 1, that is HF. So HF equal to 128 Q into mu into L divided by gamma into pi into d to the power 4. Before solving the equation using dimensionally homogeneous concept, we have to know the terms involved in that expression or equation. So what is HF? HF is a friction head in meter, and Q, that is volumetric flow rate, or it is called as discharge in meter cube per second, and mu, that is coefficient of viscosity or dynamic viscosity, and L, that is length in meter, and mu, that is viscosity in Newton second per meter square, and gamma, that is specific weight in Newton per meter cube, or other unit is kg meter into second to the power minus 2, because expression for gamma is rho into g, that is density into acceleration due to gravity. Then d, that is a diameter in meter. So L, where L is a length in meter, gamma is specific weight in Newton per meter cube or kg meter to the power minus 2 into second to the power minus 2, comma d is a diameter in meter. That's what I told. The dimensions for various variables are, first let's go for HF. There's a friction head. Head means it is a distance, so it is measured in meter. So dimension becomes, for meter it is L. So HF equal to L. Next Q, that is meter cube per second. So dimension is L cube into t to the power minus 1. Then length L, that is actually the unit of length is meter. So dimension becomes L. Then viscosity mu, the unit is Newton second per meter square. Now we have to replace Newton. So how to replace Newton? So that is from Newton's second law of motion. That is F equal to m into a. That is mass into acceleration. Unit of mass is kg and acceleration is meter per second square. So overall unit for Newton or force becomes kg into meter into s to the power minus 2. So here it is a dynamic viscosity Newton second per meter square. So we have to multiply Newton into second divided by meter square. So what is the final dimension? So dimension becomes m into L into t to the power minus 2, that is for Newton, into t divided by L square. So upon cancelling same term, we get for dimension expression for mu as mu equal to m into L to the power minus 1 into t to the power minus 1. Then gamma, as I already told, unit is kg meter to the power minus 2 s to the power minus 2. So dimension becomes m into L to the power minus 2 t to the power minus 2. Then diameter, that is measured in meter, so dimension is L. So here let's start with the LHS side of the equation. LHS side of the equation is equal to HF. There's a friction head. So dimension we already calculated, that is L. Next RHS side of the equation, 128 into Q into mu into L divided by gamma into pi into d to the power 4. So 128, where 128 is a constant, it has no unit, so it has no dimension. Now we have to write expression for q into mu into L divided by gamma into pi into d to the power 4, we have to calculate the dimension. So that can be done like this. So q has dimension LQ into t to the power minus 1 into mu has dimension m into L to the power minus 1 into t to the power minus 1. Then L has a dimension L. So divided by gamma into pi d to the power 4, where pi has value 3.143, that is again constant, it has no dimension or unit, so there is no dimension for pi. So remaining, that is gamma into d to the power 4. For gamma it is m into L to the power minus 2 into t to the power minus 2 into L to the power 4 for diameter to the power 4. So overall dimension becomes for RHS, that is L. So we can see here LHS and RHS dimensions are equal. So dimension of LHS equal to dimension of RHS. Therefore equation HF equal to 128 Q into mu into L divided by gamma into pi into d to the power 4 is dimensionally homogeneous. So because both its sides of the equation has same dimension or same unit, so it is dimensionally homogeneous. So next, second case, P equal to 4 sigma by D. So there's an expression for pressure. So that is actually pressure inside the droplet. So in surface tension, sigma is surface tension and D is the diameter of the droplet or the bubble. So P is a pressure in Newton per meter square. There's a unit of pressure, or alternative unit is Pascal. Then sigma is surface tension in Newton per meter. There's a force acting per unit length, that is called a surface tension. Then D is the diameter, as we all know, that is in meter. So we have to write dimensions of the different variables as follows. P, that is a pressure, Newton per meter square. For Newton it is m into L into t to the power minus 2 because of F equal to ma expression. So divided by meter square, m into L into t to the power minus 2 divided by L square. So we are going to get m into L to the power minus 1 t to the power minus 2 for as expression for dimension for pressure. Then sigma, that is a surface tension, Newton per meter. For Newton it is m into t into L into t to the power minus 2 divided by L, that is m into t to the power minus 2. Then for diameter, that is measured in meter, so dimension is L. So LHS, so for LHS is a pressure term, so P equal to m into L to the power minus 1 t to the power minus 2 as dimension for pressure. Now let's write on RHS dimension. RHS equal to 4 sigma by D, where 4 is a constant, so it has no unit or dimension. So keep you can neglect the 4. So remaining dimensions we have to write for sigma and D. So sigma it is m into t to the power minus 2 divided by L for D. So overall dimension becomes m into L to the power minus 1 into t to the power minus 2. So therefore dimension of LHS equal to dimension of RHS, that is equal to m into L to the power minus 1 into t to the power minus 2. Therefore equation, that is for pressure, P equal to 4 sigma by D is dimensionally homogeneous. So that is the second problem. Next, third one, m dot equal to rho AB. So m dot is a mass flow rate in kg per second. You don't consider it as a mass is measured in kg. Here it is clearly given m dot means it is a kg per second, or it is a mass flow rate. So and rho, that is a density, A is cross sectional area, and V, again most of the guys are getting confused here, that is not volume, there's a velocity in meter per second. For volume it is small letter V, so you have to remember that thing. So m dot equal to rho into A into V. So unit of rho is kg per meter cube, and unit of area is meter square, and unit of E is meter per second because it is a velocity. Next, let's write on the dimensions for variables. So m dot kg per second, kg, for kg it is m, per second it is t, so m into t to the power minus 1 for m dot. Then rho, kg per meter cube, so m into L to the power minus 3. Then area, that is meter square, so dimension is L square. Then V, that is velocity, L into t to the power minus 1. Next, let's start with LHS. LHS equal to m dot, is the m dot term, so that is equal to m t to the power minus 1 for dimension for LHS. Then dimension for RHS equal to rho AB. So for rho it is m into L to the power minus 3, and area it is L square, and velocity it is L into t to the power minus 1. So upon combining all these terms, we can add together. So we are going to get m into t to the power minus 1. So we can see here LHS equal to RHS. So therefore, dimension of LHS equal to dimension of RHS, that is equal to m into t to the power minus 1. Therefore, equation m dot equal to rho AV is dimensionally homogeneous. Next, fourth one, pressure equal to rho GH. So P is a pressure, small letter pressure. So then rho is density, G is acceleration due to gravity, H is the head or height in meter. So where P is a pressure in Newton per meter square, rho is density in kg per meter cube, G is acceleration due to gravity in meter per second square, H is head or height in meter. So let's write down the dimensions of the variables. So I already told about dimension of pressure in previous problem. So no need to explain again here. So pressure equal to m into L to the power t minus 1 into t to the power minus 2. There's a dimension for P, pressure. Then rho m into L to the power minus 3. G, that is equal to L into t to the power minus 2, and H, that is L. So let's start with LHS. LHS, there's a pressure. P equal to m into L to the power minus 1 t to the power minus 2, that is for pressure. Next, RHS, rho GH. So rho is a density, G is acceleration due to gravity, H is the head. For rho it is m into L to the power minus 3, and G it is L into t to the power minus 2, and H it is L. So upon combining that, we get m into L to the power minus 1 into t to the power minus 2. So we can see here LHS equal to RHS dimension. So dimension of LHS equal to dimension of RHS. Therefore equation P equal to rho GH is dimensionally homogeneous. So there is a fourth case. Next, last case, pressure equal to F by A. So P is a pressure, F is a normal force acting on an area. So F by A. So F is a force and A is a cross-sectional area. Where P is in pressure in Newton per meter square, F is force in Newton, and A is area in meter square. Then we can write dimensions of the variable because we know all the units of the parameters. So we can write the dimension. For pressure it is m into L to the power minus 1 t to the power minus 2. For force from Newton's second law, F equal to ma, we have dimension as m into L into t to the power minus 2. Area it is L square. So we can start with LHS. LHS we have pressure. So dimension of pressure is m into L to the power minus 1 into t to the power minus 2. Similarly, dimension for RHS, that is F by A. For force it is m into L into t to the power minus 2 divided by 4, area it is L square. So m into L to the power minus 1 into t to the power minus 2. There is a dimension for RHS. So we can see here LHS dimension is equal to RHS dimension. Therefore equation P equal to F by A is dimensionally homogeneous. So this is a case we have to prove here in this type of problem, very important. We have to prove left hand side dimension should be equal to right hand side dimension. There is a case in dimensional homogeneous problems. So let's go for now Rayleigh method. This is a second method in this syllabus or in this portion. So using Rayleigh method, show that power P developed by a hydraulic turbine is given by P equal to rho into n cube into d to the power 5 into phi of n square d divided by g comma d by h, where rho is a density of liquid, n is a rotational speed of turbine in rpm, d is diameter of the runner, h is working head, g is equal to gravitational acceleration or acceleration due to gravity. This was a question asked in June-July 2017. So now here we can in Rayleigh method, first step to classify the parameters, that is independent and dependent variables, into two categories. There's like which parameter is dependent on which, that is like dependent or independent. So I have to classify the variable into two categories, independent and dependent. So now we can see the expression P. So P equal to, so P is a dependent parameter, whereas rho, n, d, g and h, those are independent parameters. So we have to get expression for dependent parameter as a function of independent parameters. So expression it is given in problem itself. We have to prove that expression. Now, so let's start with the first step. So power it is given as a function of rho n d comma g h. So where rho is the density, n is rotational speed, and d is diameter, g is gravitational acceleration, and h is head. Now we have to write in the form of expression dependent parameter equal to product of constant into power of independent parameters. So that is p equal to k into rho to the power a into n to the power b into d to the power c into g to the power d into h to the power e. Take it as expression 1, where k is non-dimensional constant, a, b, c, d, e are exponents. Now let's start with writing the dimensions for various parameters. First, for dependent parameter, that is power. So power, that is actually joule per second, or it is, instead of joule you can write Newton meter per second, because joule is a unit of work. So what is the expression for work? Work equal to force into displacement. So unit of force is Newton and displacement it is measured in meter. So Newton meter. So power is rate of change of work. So work by time, Newton meter by time, that is Newton meter per second. There is a unit for power. So we know how to write dimension for Newton from second law, F equal to ma. So I can write expression for power as m into L square into t to the power 3. Then rho, that is kg per meter cube. So dimension becomes m into L to the power minus 3. So n, that is a rotational speed in rpm, revolution per minute. So revolution, it has no unit. So per minute is minute is unit of time. So it becomes, per means it is divided by something. So when it goes to the numerator, it becomes t to the power minus 1. T is a dimension for minute. So d, that is diameter. So it is measured in meter. So dimension is L. Then g, that is acceleration due to gravity. Unit is meter per second square. So dimension becomes Lt to the power minus 2. Then h, that is head. So dimension is L. So we can substitute now the corresponding dimensions of quantities in equation 1. So equation 1 is this one, p equal to k into rho to the power a into n to the power b into d to the power c into g to the power d into h to the power e. So we can substitute there. So upon substitution we get m into L square t cube equal to k into m into L to the power minus 3 to the power a into 3 to the power minus 1 to the power b into L to the power c into Lt to the power minus 2 to the power d into L to the power e, upon substitution of dimension of dependent and independent variable in equation 1. So now next step in Rayleigh method is equating the power. So or following the dimensional homogeneity concept. So let's go for equating the power of m, L and t. So first let's go for equating the power of m. So we can see, as we can see there, left hand side m to the power 1, so power is 1, and right hand side it is m to the power a, so only one m to the power a is there, so a equal to 1. So this is from equating the power of m. Next, equating the power of L. On left hand side we have L square, and right hand side L to the power minus 3a, L to the power c, L to the power d and L to the power e. So we get expression as 2 equal to minus 3a plus c plus d plus e. So now we know the value of a. So 2 equal to minus 3 into 1 plus c plus d plus e. So upon rearrangement we get c plus d plus e equal to 5. Take it as expression 3. Next, equating the power of t. On left hand side we have 3, t to the power 3. Right hand side we have t to the power minus b, t to the power minus 2d. So we get expression as 3 equal to minus b minus 2d. So we can rearrange that expression in order to get b equal to 3 minus 2d. So now the concept here is of expression 2 we got a equal to 1, and expression 3 c plus d plus e equal to 5, and expression 4 3 equal to minus b minus 2d. Now we can see there in expression 3 and 4 what is the common term? D is the common term, so we can express equation 3 and equation 4 in terms of d. So upon doing that we get b equal to 3 minus 2d, c equal to 5 minus d minus e. Can you guess the reason why we are doing like this? That is just because we have 5 unknowns but equations are 3. So you cannot solve the simultaneous equation, so we should go for elimination method. Now what is elimination method? Expressing the 3 parameters in terms of remaining 2 parameters, that is called as elimination. Here we are expressing b and c in terms of d and e. So we can eliminate 2 parameters by using elimination concept. So now substituting these values in equation 1 we get, so p equal to k into rho to the power 1 as value of a is 1 into n to the power 3 minus 2d because value of b is 3 minus 2d into d to the power 5 minus d minus e because c value is 5 minus d minus e into g to the power d s to the power e as it is. So next simplification, P equal to K into rho n cube, taking rho out, and n cube from n to the power 3 minus 2d into 1 divided by n to the power 2d. So we have n to the power minus 2d. So minus 2d that goes to the denominator and becomes n to the power 2d, positive value. So 1 divided by n to the power 2d into d to the power 5, taking d to the power 5 out from d to the power 5 minus d minus e, and taking d to the power d to denominator. So because it becomes positive when it goes to the denominator, into g to the power d as it is, into h to the power e divided by d to the power e. This d to the power e, that is from d to the power 5 minus d minus e. So d to the power minus e, when it goes to denominator, becomes plus e. So d to the power e. So simplification, P equal to K into rho n cube into 1 divided by n to the power 2d into d to the power 5 divided by d to the power d into g to the power d into h to the power e divided by d to the power e. Now P equal to K into, I can club together terms without the parameters d and e. So rho into n cube d to the power 5 into g divided by d n square to the power d. So clubbing together d power terms together, we have d power terms, one is g, other one is d, and other one is n. So it becomes d divided by d n square to the power d. Similarly clubbing together h and d with the power e. So h divided by d to the power e. So P equal to, we are K into rho n cube d to the power 5 function of g divided by n square d comma h by d. So we can neglect here k, because as k value is not given in expression in a given problem, so we can just consider k equal to 1, or you can combine that k with the parameter 5. So power equal to rho n cube d to the power 5 function of n square d divided by g comma d by h. So in this dimensional analysis problem, we can take the reciprocal inside the bracket, that is g divided by n square d comma h by d, because it is a function of some parameter. Even if you are going to take reciprocal also, it remains function only. So P equal to rho n cube d to the power 5 function of n square d divided by g comma d by h upon taking reciprocal inside the bracket. So this problem is a little bit trickier to know here, and k value we consider it as 1. So this is the first case or first problem. Next, let's go for second problem. Find the expression for power P developed by a pump when P depends upon head h, discharge q, and specific weight W of the fluid. So here they told to find the expression for power. So power is a dependent parameter, whereas remaining, that is head, discharge, and specific weight, those are independent parameters or variables. So we can write expression as P equal to function of h comma q comma w, or we can write the dependent parameter in terms of constant and power to the dependent parameter as P equal to k into h to the power a into q to the power b into w to the power c. Take it as expression 1. Now where there is a k is a non-dimensional constant, abc are exponents or constants, abc values. So the dimension, first you have to write dimensions of power h, q, and w. So how to write h, that is measured in meters, so dimension becomes L. Then q, that is discharge or volumetric flow rate in meter cube per second, so dimension becomes LT to the power minus 3. Then w, there is a specific weight, Newton per meter cube, or w equal to rho g, or it can be represented by a symbol gamma. So rho has a unit kg per meter cube, g has a unit meter per second square. So we can, by using that concept, we can write the dimension as for specific weight as w equal to m L to the power minus 2 t to the power minus 2. So power, as I already explained, joule per second or Newton meter per second. By using that, we can get expression for power as m L square t to the power minus 3, as p equal to work by time. So unit of work is Newton meter, because work is equal to force into displacement. Then in place of Newton, we can replace force equal to mass into acceleration, kg meter into second to the power minus 2. So in this way we can get dimension for power. Next, substituting dimensions on both sides of the equation 1, that is power equal to k into h to the power a, q to the power b into w to the power c. We get m L square t to the power minus 3, that is equal to k into L to the power a into L t to the power minus 3 to the power b into m L to the power minus 2 t to the power minus 2 to the power c. So that is upon substituting dimension on both sides of the equation, that is p equal to k into h to the power a into q to the power b into w to the power c. So now next step, we have to equate the powers of m, l and t, that is a fundamental dimension of primary quantity, on both sides of the equation, or that is a concept of dimensional homogeneity. So now equating the power of m, we get on left hand side we have m to the power 1, so that is equal to 1. So on right hand side we have m to the power c, that is c. So 1 equal to c, therefore c equal to 1, that is a value of c. Next, power of l, equating the power of l. On left hand side we have l square, right hand side we have l to the power b, l to the power a, l to the power minus 2c. So we can write expression as 2 equal to a plus 3b minus 2c. Similarly, equating the power of t. On left hand side we have t to the power minus 3, and right hand side we have t to the power minus 3b, t to the power minus 2c. So we can write expression for t as minus, using the concept of equating the power of t as minus 3 equal to minus b minus 2c. So by using concept, this thing we can write like that. Next, similarly, now we can see there we have values of c as 1, so we can substitute value of c in equation 3, that is minus 3b equal to minus b minus 2c. So from that we can get value of b as b equal to minus 3 minus 2c. So in place of c we have value of c as 1, so 3 minus 2 into 1, so we get value of b as 1. Similarly, we can substitute now values of b and c in expression for a, that is a equal to 2 minus 3b plus 2c. We get 2 minus 3 plus 2 because b and c values are 1, so we get value of a as 1. Now substitute the values of a and b, a, b, c in equation 1. That equation 1 is p equal to k into h to the power a, q to the power b, w to the power c. So we get p equal to k into h to the power 1, q to the power 1, w to the power 1. So as values of a, b and c are 1. So that is equal to k into h into q into w. That is the expression for power. Next, third problem. The efficiency eta of a fan depends on density rho, dynamic viscosity mu of the fluid, angular velocity omega at a diameter d of the rotor, and discharge q. Express eta in terms of dimensionless parameters. So eta, that is the efficiency. Efficiency is given by output by input. So it has no unit. If it is not having unit means it has no dimension. So it is dimensionless. So I can write dimension of eta as m to the power 0, l to the power 0, that is equal to t to the power 0. So it is given, you have to find out expression for efficiency. So efficiency is dependent parameter. So what are the independent parameters? So density, viscosity, angular velocity, diameter and discharge, those are independent parameters. So we can write expression using Rayleigh method, eta equal to k into rho to the power a into mu to the power b into w to the power c, omega to the power c, sorry, then it's not w, omega to the power c, d to the power d into q to the power e. So where k is non-dimensional constant, a, b, c, d are exponents. Now dimension for rho, that is kg per meter cube, so m into l to the power minus 3, mu ml to the power minus 1, t to the power minus 1, omega, that is the angular velocity, that is measured in radian per second. Radian has no unit, and for second it is t, so per second, so it becomes to t to the power minus 1 when it goes to numerator. Then d equal to l, unit of diameter is meter, so dimension for diameter is l. Then q, that is the discharge, meter cube per second, so dimension becomes l cube into t to the power minus 1. So substituting dimensions on each side of the equation 1, that is eta equal to k into rho to the power a into mu to the power b into omega to the power c into d to the power d into q to the power e. We get m to the power 0, l to the power 0, t to the power 0, that is equal to k into ml to the power minus 3 to the power a into ml to the power minus 1 into t to the power minus 1 to the power b into t to the power minus 1 to the power c into l to the power d into l cube t to the power minus 1 to the power e. So just substituting the dimension on both sides of the equation, LHS and RHS. We can use concept of equating the power of MLT, that is fundamental dimension. First let's go for equating the power of m. So on left hand side we have m to the power 0, so power is 0. Right hand side m to the power a, m to the power b, so that's it. So we get expression 0 equal to a plus b. Take it as expression 2. Then equating the power of L, on left hand side we have L to the power 0, so power becomes 0, and right hand side we have L to the power minus 3a, L to the power minus b, L to the power d, and L to the power 3. So we can get expression as 0 equal to minus 3a minus b plus d plus 3. Take it as expression 3. Then equating the power of t, that is on left hand side we have t to the power 0, right hand side we have t to the power minus b, t to the power minus c, and t to the power minus z. So we get expression 0 equal to minus b minus c minus z. So take it as expression 4. But problem here is we have 3 expressions from equating the powers of m, l and t, but we have 5 unknowns a, b, c, d, e. So how to solve this type of problem? Again, you should go for elimination method, that is expressing 3 variable in terms of remaining 2 variable. So let me discuss about the theory here. There are 5 unknowns but equations are 3. Express the 3 unknowns in terms of other 2 unknowns which are more important. Viscosity and discharge are more important in this problem, hence expressing A, C, D in terms of B and E. So B and E, that is actually power to viscosity and discharge. Otherwise you can, I'll tell you the important step or important method here. You need not worry about which parameter is important here. So you can see the equation second, third and fourth. What is the common term in all 3 expressions? So B is the common. So I express A in terms of B, that is A equal to minus B. And equation third and fourth, we can see here E is a common term. So I can express equation 3 and equation 4 in terms of E. So I get the expression for C, that is equal to minus B minus E, that becomes minus into B plus E from equation 4. Similarly, expression 3, I can give expression for D as D equal to 3A plus B minus 3E. Now, I know the expression for A as minus B. So, I will substitute in place of A as minus B. So, minus 3 into B plus B as it is minus 3E. So, I get expression as minus 2B minus 3 for D. Now, substituting these values, so we can see here AC and D, that is expressed in terms of B and E. So we reduced 5 unknowns to 3 unknown problem. So now substituting these values in equation 1, so we get eta equal to k into rho to the power minus b into mu to the power b into omega to the power minus b plus e into d to the power minus 2b minus 3e into q to the power e. Just substituting values of a, b, c, d, e. So now we can simplify or split of the terms. So eta equal to k into rho to the power minus b into mu to the power b. So I'll split up now omega to the power minus b plus e as omega to the power minus b into omega to the power minus e into d to the power minus 2b into d to the power minus 3 upon splitting up of d to the power minus 2b minus 3 into q to the power e. So now I'll club together b power term and e power term. So k into mu divided by rho omega d square to the power b, because rho has value minus b and omega has value minus b. Omega has value omega to the power minus b and d square, that is d to the power minus 2b. So when omega to the power minus b and rho to the power minus b, d to the power minus 2b, that goes to denominator, then it becomes rho to the power b, omega to the power b, d to the power 2b. So I can club together now mu divided by rho omega d square to the power b. Similarly, expression for power of e. So q divided by omega into d cube to the power e. Now I'll express these powers in terms of some parameter. So k into function of our pi of mu divided by rho omega d square comma q divided by omega d cube. So we can just ignore or neglect these powers, because it is a function of power, means it should be a function of parameter without power. So k into phi into function of mu divided by rho omega d square comma q divided by omega d cube. There's an expression for efficiency of a fan. Next problem. The resisting force R of supersonic plane during flight can be considered as dependent upon length of the aircraft EL, velocity V, air viscosity mu, air density rho, and bulk modulus of air K. Express the functional relationship between these variables and resisting force. So this problem is related to supersonic plane. So there is a resistance force R. So R is dependent upon the length of the aircraft, then velocity, viscosity, density and bulk modulus. So here R is dependent, whereas length, velocity, viscosity, density and bulk modulus, those are independent parameters or variables. So first I have to know the units of these dimensions. So R is the resisting force. So unit is from F equal to MA, kg into meter into second to the power minus 2. Then length it is meter, velocity meter per second, viscosity Newton second per meter square, density kg per meter cube, bulk modulus K. So that is given by increase of pressure divided by volumetric strain. So increase of pressure means dP. Volumetric strain means change in volume divided by original volume. So you can cancel volume in it there. So volumetric strain is unitless. So what is the unit of K then? So unit of K is unit of change in pressure or increase of pressure. So pressure has unit Newton per meter square or Pascal. Otherwise it is equal to unit of Young's modulus. So same thing. So unit of Young's modulus, unit of pressure and bulk modulus, that is one and the same. So now I can write the dimensions of variable R equal to M into L into T to the power minus 2 by using formula F equal to MA. Then length it is L, velocity meter per second, so L into T to the power minus 1. Then mu it is Newton second per meter square, so dimension becomes M into L to the power minus 1, T to the power minus 1. Then rho it is M into L to the power minus 3 as unit is kg per meter cube. Then K, that is actually pressure, same as pressure dimension. So M into L to the power minus 1, T to the power minus 2. Pressure unit is Newton per meter square. So force unit is Newton. So in place of force you can substitute kg into meter into S to the power minus 2 divided by meter square. So we can get a dimension for bulk modulus. So now I have to express dependent parameter as a function of or product of constant and independent to the power or some exponents. So R equal to A into L to the power A, V to the power B, mu to the power C, rho to the power D into K to the power E. Now can you guess why I have used here A as a constant? It's because you can see here already the K is given for bulk modulus. It is already given in problem. If you are going to use K as again constant, then you will get confused. So in order to avoid that thing, I used A as some constant, or you can go with B also. Other than that, C also you can go. So that is like it is left to you. So R equal to A into L to the power A, V to the power B, mu to the power C, rho to the power D, K to the power E. Take it as expression 1. So where A is a non-dimensional constant. So substituting dimensions on both sides of the equation, we get for force, that is a resisting force, M into L into T to the power minus 2, that is equal to A into L to the power A into L to the power L into T to the power minus 1 to the power B into M L to the power minus 1 T to the power minus 1 to the power C into M into L to the power minus 3 to the power D into M into L to the power minus 1 T to the power minus 2 to the power E. So writing the dimension on both sides of the equation, that is LHS and RHS. Now next step is equating the power of MLT. There is a fundamental dimensions. So equating the dimension of equating the power of M. So left hand side we have M to the power 1. Right hand side we have M to the power C, M to the power D, M to the power E. So I can write expression as 1 equal to C plus D plus E. Take it as expression 2. Next, equating the power of L. So upon equating the power of L, on left hand side we have L to the power 1. So 1 equal to right hand side L to the power B, L to the power minus C, L to the power minus 3D, L to the power minus Z. So I get expression 1 equal to A plus B minus C minus 3D minus Z. Then equating the power of T, on left hand side we have T to the power minus 2. So minus 2 equal to, on right hand side T to the power minus B, T to the power minus C and T to the power minus 2E. So I can get expression as minus 2 equal to minus B minus C minus 2E. Take it as expression 4. Now we have 3 expressions but unknowns are 4. So we have to express 3 variables in terms of remaining 2. There's an elimination method. So when we can see here in expression 2nd, 3rd and 4th. So what is a common term? C and D, that is a common. So we can express C and E, remaining variables in terms of C and E. So upon doing that, I can get expression for D as D equal to 1 minus C minus E, that is from equation 2nd. Then from using equation 4, expressing B in terms of C and E. So B equal to 2 minus C minus 2E. So that is from equation 4. So then equation 3rd, from using equation 3rd, a equal to 1 minus b plus c plus 3d minus e. Now I have value of b and as well as value of d. So I substitute here, that is equal to 1 minus 2 minus c minus 2e plus c plus 3 into 1 minus c minus e plus e. So upon simplification, I get expression as 1 minus 2 plus c plus 2e plus c plus 3 minus 3c minus 3e plus e, that is equal to 2 minus c. So I have values of a, d and b in terms of c and a. So we express three variables, that is a, b and d in terms of c and e. There is an elimination method. Now I'll substitute that values of a, b and d in equation 1. I get expression for r as r equal to a into L to the power 2 minus c, as value of a is 2 minus c into rho into v into v to the power 2 minus c minus 2e into mu to the power c into rho to the power 1 minus c minus e into k to the power e. Now I can split the term, so that is equal to r equal to a into L square, taking L square from L to the power 2 minus c and taking v square from v to the power 2 minus c minus 2e and taking rho from rho to the power 1 minus c minus e. I get expression as a into L square v square rho into clubbing together c terms, c power terms, mu to the power c, L to the power minus c, v to the power minus c into rho to the power minus c into v to the power minus 2e into rho to the power minus c into k to the power e. So clubbing together c power terms and e power terms together. So that is equal to a into L square v square rho into mu divided by Lv rho to the power c. So when L to the power minus c and v to the power minus c, rho to the power minus c, that goes to denominator, that becomes L to the power c, v to the power c, rho to the power c. We have mu to the power c in numerator, so we can combine together. So expression becomes mu divided by Lv rho to the power c. Similarly for e, k divided by rho v square to the power e. So final expression equal to r equal to a L square v square rho. I am expressing as a function of some parameter phi. Phi of mu divided by Lv rho, comma k divided by rho v square. So you can just neglect the powers by expressing it as a function of some parameter phi. So there is an expression for resisting force R. So next problem, a partially submerged body is stored in water. The resistance R to its motion depends on density rho, the viscosity mu of water, length L of the body, velocity v of the body and acceleration due to gravity g. Show that the resistance to the motion can be expressed in the form r equal to rho L square v square phi of mu divided by rho vl, comma Lg divided by v square. So this is a partially submerged body, so resistance to its motion is dependent on rho Lv and g. So to express resistance in terms of rho, L, V and mu and again g. So this is like here resistance is a dependent parameter, whereas density, viscosity, length and velocity, those are independent parameters. So then again acceleration due to gravity, those are independent parameters. So I can get right expression for r as r equal to k into rho to the power a into mu to the power b into L to the power c into v to the power d into g to the power e, expressing r in terms of some constant k and with the powers of independent variables. So take it as expression 1. So now writing the dimension, as we all know, unit of or dimension of force. So I'll write directly here, r equal to m into L into t to the power minus 2, rho equal to m into L to the power minus 3, mu equal to m L to the power minus 1 t to the power minus 1, because unit of mu, there is dynamic viscosity is Newton second per meter square, length it is L, velocity is meter per second, so dimension becomes L t to the power minus 1, acceleration due to gravity it is meter per second square, so dimension is L t to the power minus 2. Now next step, substituting the dimension on both sides of the equation. So I get expression as ml t to the power minus 2, that is equal to k into m into L to the power minus 3 to the power a into m into L to the power minus 1 t to the power minus 1 to the power b into L to the power c into L t to the power minus 1 to the power d into L to the power L into t to the power minus 2 to the power e. So just writing dimension on both sides, LHS and RHS. Now next step, equating the powers of fundamental quantities, that is ml and t. So first let's go for equating the power of m. So on left hand side we have m to the power 1, on right hand side we have m to the power a, m to the power b. So 1 equal to a plus b, take it as expression 2. Then equating the power of L. So on left hand side we have L to the power 1, right hand side L to the power minus 3a, L to the power minus b, L to the power c, L to the power d and L to the power e. So I get expression as 1 equal to minus 3a minus b plus c plus d plus e. Take it as expression 3. Next, equating the power of t. So on left hand side we have t to the power minus 2, right hand side t to the power minus b and t to the power minus d and t to the power minus 2e. So I can get expression as minus 2 equal to minus b minus d minus 2e. Now we can see here in equation second, third and fourth we have to look into common terms. So this a common term is b. So I'll express equation second in terms of b. So a equal to minus 1 minus b. Then in equation third and fourth, what is the common term? That is common term is e. So I'll express equation third and fourth in terms of b and e. So I get expression by using fourth expression as for d equal to minus 2 minus b minus 2e. So just rearranging the expression for I can get expression for d as 2 minus b minus 2e. Then similarly rewriting the expression third, so I get expression for c as 1 plus 3a plus b minus d minus z. Now we have values of a and d. So I can substitute here 1 plus 3 into 1 minus b plus b minus 2 in place of d 2 minus b minus 2e minus z. Upon simplification 1 plus 3 minus 3b plus b minus 2 plus b plus 2e minus z. So we get that is equal to 2 minus b plus e. So that's the expression for c. We express ADC in terms of b and e because we have 5 unknowns but equations are only 3 from equating the powers of ml and t. So I have to eliminate 2 variable. So that can be done like this, expressing ADC in terms of b and e because b and e is a common term for all the expressions. So next, substituting these values in equation 1, we get r equal to k into rho to the power 1 minus b into mu to the power b into L to the power 2 minus b plus e into v to the power 2 minus b minus 2e into g to the power e. Now next step, we have to split up the term. So r equal to k into rho to the power 1 minus b into mu to the power b into L to the power 2 minus b plus e into v to the power 2 minus b minus 2e into g to the power e. Now we can just split off the term. So k into rho into L square v square, taking rho from rho to the power 1 minus b and L from L to the power 2 minus b plus e and v square from v to the power 2 minus b minus 2e. So k into rho into L square v square. So remaining terms in rho to the power 1 minus b is rho to the power minus b. In rho to the mu to the power b, keep as it is. L to the power minus b into v to the power minus b, writing remaining terms into L to the power e into v to the power minus 2e into g to the power e. So now we can just rearrange k into rho into L square v square mu divided by rho LV to the power b, because rho LV it has negative power, so that is rho to the power minus b, L to the power minus b, v to the power minus b. When it goes to denominator, it becomes positive. So mu to the power b, that is anyhow positive, so I can club together those terms. Mu divided by rho LV to the power b into LG divided by v square to the power e, similar to writing expression related to power of b. So a final expression for r becomes r equal to rho L square v square function of or phi of mu divided by rho LV comma Lg divided by v square. So just neglecting the power because we are expressing as a function of some parameter. So we can just ignore the power. So mu divided by rho LV comma Lg divided by v square. So function. So there is an expression for resisting force. So there is a problem. Now let's these are the questions for your assignment. Take it as assignment. You can solve these problems and you can submit before 4 p.m. So just check. These are the problems related to dimensional homogeneity and as well as Rayleigh method. So first problem, check whether the following equations with their usual notations are dimensionally homogeneous or not. So this is related to first case. You have to check whether the given equations are dimensionally homogeneous or not. How to check? So dimension or in unit should be on both the sides should be equal. So you have to know, before doing that, you have to know the terms involved in this expression. So let me just discuss about the terms involved in given expressions. So first one, tau equal to mu into du by dy, where tau is a shear stress. So you know stress is the force by area. So unit is Newton per meter square. Then mu, dynamic viscosity, unit is Newton second per meter square. Then du, change in velocity, so that is in meter per second. Then dy, the change in length, so unit is meter. Second one, h equal to 4 sigma cos theta divided by rho gd. This is expression for capillary rise. So h, that is a head or height, rise in head or height. So that is expressed in meter. 4, it is anyhow constant. Sigma is surface tension force acting per unit length. The unit is Newton per meter. Cos theta, it has no unit, so no dimension, divided by rho gd. So rho is density kg per meter cube, g is acceleration due to gravity meter per second square, d is diameter of the tube in meter. Then third one, this is an expression for triangular notch discharge. So q equal to 2 by 3 cd into l into square root of 2g into s to the power 3 by 2. So 2 by 3, it is anyhow constant. cd, that is called as coefficient of discharge. As this is a coefficient, it has no unit or dimension. So L, it is length in meter, and G, it is acceleration due to gravity meter per second square. So H, it is head or height, that is in meter. So there's an expression of, and Q, that's the discharge or volumetric flow rate in meter cube per second. It is not heat transfer. Just remember that term. Then fourth one, Q equal to CD into A1 A2 into square root of 2GH divided by square root of A1 square minus A2 square. A1 and A2, there's a cross-sectional area that is in meter square. Then CD, that is coefficient of discharge, no unit. And Q, that is discharge or volumetric flow rate in meter cube per second. And G, that is acceleration due to gravity in meter per second square. H, that is head in meter. So these are the problems related to dimensional homogeneous equation. So second, the variables controlling the motion of floating vessel through water are the drag force F, the speed V, the length L, the density ρ, and dynamic viscosity mu of water, and acceleration due to gravity G. Derive an expression for F by dimensional analysis. So they told to derive expression for F. So F is dependent parameter, whereas ρ, L, V, and G and mu, that is, those are independent parameters. So we have to get expression, final expression as F equal to ρ L square V square function of mu divided by ρ VL comma LG divided by V square. That is the answer. So we have to try that using Rayleigh method. Next, the resistance R to motion of completely submerged body depends upon the length of the body L, velocity of flow V, mass density of fluid ρ, kinematic viscosity of the fluid nu. By dimensional analysis, prove that R equal to ρ V square L square phi VL divided by nu. So R is a resistance, so it is a force. So unit of force is Newton. So for Newton, we can get expression from dimension from F equal to ma, that is kg into meter into s to the power minus 2. Then ρ, it is a density in kg per meter cube. V is velocity in meter per second. L is length in meter. And nu, there is a kinematic viscosity that is given by dynamic viscosity divided by a density. So we get expression a unit of nu as meter square per second. So dimension becomes L square t to the power minus 1. There is a dimension for kinematic viscosity. This is a new term. So you have to remember that. Next, last problem. A fluid of density ρ and viscosity mu flows at an average velocity v through a circular pipe of diameter d. So show by dimensional analysis that shear stress at the pipe wall is given as tau naught equal to ρ v square phi of ρ v d divided by mu. So tau naught, there is a shear stress. Stress, it is force by area. So Newton divided by area, that is Newton per meter square. So Newton F equal to ma, kg into meter into s to the power minus 2. So you can get expression for tau naught. Similarly, ρ, that is a density, kg per meter cube. So you can get the dimension easily. Then V, that is a velocity. So we can get dimension for V as well. Then to express as a function of ρ v d divided by mu, where mu is a dynamic viscosity, unit is Newton second per meter square. This is a somewhat tricky problem. Just try this fourth question, but it is very important. So these are the problems related to dimensional analysis using Rayleigh method and dimensionally homogeneous equation. So in next video, I will come up with solving the problem using Buckingham's pi theorem and its application. Okay, thank you.